All right, now we're going to talk about gas and speed and velocity and things like that. All right, when you've all experienced having a balloon that had helium in it, and over time that balloon slowly came down and ended up on the ground. The reason for that is what we call effusion. Effusion is the way a gas escapes through a tiny hole, and all balloons have tiny holes. If you've ever gotten latex balloons, you know that they'll put some kind of a liquid liner or something that helps stop up some of those holes so they stay filled up longer. Stay float maybe is what it's called. And that helps to block up some of those teeny tiny holes in the latex. Even the mylar balloons have teeny tiny holes. So those gas particles can move out. So if you think about that, as the gas particles are trying to escape, the bigger the molecule, the harder it is going to be to get out of that teeny tiny hole. And that's the whole concept of effusion. Small gases move through quickly. Large gases move through slowly. The other concept here to talk about is diffusion. It's not in the notes, but diffusion is the process by which a gas moves across a space. And the classic one here is the fart smell. When someone on one side of the room farts, and you can see when it reaches each of the people across the room. You tend to see that in funny skits on things like that. Or my dog, well, not Teddy, he's bad, but we had a dog named Lucy, and Lucy could clear a room, and you could tell when the smell got to you, because those people would get up and run. Not walk, run. That's diffusion, that's just movement of gases, and you learned about diffusion in biology. All right, so effusion, the way we can figure out effusion is it's a ratio. If you know the molar masses, the rate of the effusion of gas 1 divided by gas 2 is equal to the square root of the molar masses of 2 divided by 1. And you can just plug the numbers in. All right? So, problem. Under the same conditions of temperature and pressure, how many times faster will hydrogen effuse compared to carbon dioxide? All right, I'm going to call carbon dioxide gas 2. Carbon dioxide has a molar mass of 44 grams per mole. And then we'll call the hydrogen gas 1. So 44 divided by 2 would be 22. Now we take the square root of 22. And we get 4.7. So hydrogen will effuse with an E, 4.7 times faster than CO2. All right, so we know that the hydrogen will diffuse 4.7 times faster than the carbon dioxide. So if the carbon dioxide takes 32 seconds to diffuse, the hydrogen is going to be 4.7 times faster than that. So we're going to divide 32 by 4.7. And the hydrogen then would be 6.8 seconds. Think about that. Next question. What is the relative rate of diffusion of ammonia compared to helium? Does ammonia effuse faster or slower? Well, we need to know the molar masses. If we're going to compare helium to ammonia, ammonia we'll put on top over helium. The molar mass of ammonia is 17, helium is 4. 17 divided by 4 is 4.25. The square root of 4.25 is 2.06. So helium should effuse 2.06 times faster than ammonia. That's the relative rate. So if it takes 20 seconds for helium to diffuse, if we multiply that by 2.06, that means it should take 41.2 seconds for the ammonia to diffuse, because it's that much slower. All right. The basic point you need to understand, though, is the heavier it is, the longer it's going to take to diffuse. That is what you need to know. The book Practice Problems has several questions about mean squared velocities, and I took those out. If there's still one in there, just skip it, because I don't think that you're going to need that information. If I find out differently, we'll fix it later.